VLSos here. This is a video lesson for geometry, formal justification, or proof. What I have here is a diagram of two triangles, and I am asked to prove that triangle ABC is similar to triangle XYZ. These capital letters are the vertices of these triangles here. A must correspond to X, because in the order that we're given here, A corresponds to X. I want to prove that these triangles are similar, and I'm going to do it in an organized manner, a very thorough process. So we can call this a proof, complete justification. These are triangles. There are three ways to prove that triangles are similar. If we're given the right information, we can use angle-angle similarity, side-angle-side, or side-side-side. These are shorthand for those theorems that justify and prove triangle similarity. So what kind of information am I starting with? It's a good idea to get a picture of which one your proof is going to use so you can head in that direction. As you go through the process of proving, it may not work out, but you can adjust along the way. If I take a look at the information given, I've got two sides in one triangle that correspond with two known sides in the other triangle. And I have an angle here that corresponds, and those measures are equal and given. It seems like I would be able to use two sides in one angle. And the theorem side angle side definitely includes those ingredients. But I've set up here the one situation that you have to be most careful of, that this angle that's given is not in between the given sides. And the order of these letters, side angle side, the angle is in between the sides. To remind you, it must be. We cannot prove that these two triangles are similar. We don't have the right kind of information. We have two sides, not three, so we can't use SSS. We have one angle, not two, so we can't use angle-angle. We have two sides in an angle, but the angle is not in between the given sides. So none of these three, and those are the only three that we can rely on, will prove that these triangles are similar. I'm going to adjust this information and make it a different problem. I'm putting this angle 85 degrees and this angle here. Now let's see if we have enough information. We still have the two sides, and we have an angle of 85 degrees that corresponds to this unknown angle. But since we have the other two angles in the triangle, we can find the measure of this angle A. And if it's equal to 85 degrees, the measure of the corresponding angle X, then we'll have the angle in between the two sides, and we can use side angle side justification. So let's do the proof. I'm going to start with facts. Facts that come from the given information in the diagram. This side BA, I can write it as BA with a line segment over it, divided by the corresponding line segment or side, YX, has measures 4 and 2. And when I set it up as a fraction like that, it's a ratio of corresponding sides. I can simplify this ratio to 2. This is a fact, and it's justified because it comes from given information in the diagram from the beginning of the problem. I also have two other corresponding sides. I can do the same thing. I can make a ratio of sides AC over XZ is equal to the given measures, 6 over 3, and that reduces to 2. This is a fact. I put it inside of a bubble or a circle, and the justification to the bottom right outside is it's based on given information. I have given angle measures. Angle B is equal to 60 degrees. Angle C is equal to 35 degrees. That information is given. And I'm going to have a separate fact bubble for the measure of angle X. Because it's in a different triangle, I'm going to separate that similar given information. I don't have anything that's directly given other than what I've already put in the facts, the fact bubbles. I need to find the measure of angle A. I can do it with the triangle sum. I start with these two angles, and I can find the measure of angle A by taking 180 degrees and subtracting the two known angles that I've got to figure out what's left. 60 plus 35 is 95 degrees. So if I take 95 degrees from 180 degrees in the three angles of the triangle, I'm left with angle A, and its measure is 85 degrees. This is not a given fact. It came from two angles that were given in the triangle, that's here, and it led me to find the third with the triangle sum theorem. So the justification is not that it's given or that it's obvious, but very specifically, I use triangle sum to calculate that angle A. Notice that sometimes I put an M in front. M is for measure. This reads measure of angle X. I could be consistent and put an M in front of those. I have enough information to prove that these triangles are similar. I have the two sides, and their ratios are equal. I have the angle in between, but I haven't established that angle A is equal to angle X. It might be obvious, but it needs to be stated explicitly. The measure of angle A is equal to the measure of angle X. Those two corresponding angles are equal. It comes from them having the same measure, 85 degrees, established in two different fact bubbles. So I have to point from these two to this one. And the justification is not that it's obvious. Technically, what we've done here is substitution. A very, very common algebra move. Two things that are equal to the same thing are equal to each other. In other words, if I take these two statements, if measure of angle X is equal to 85 degrees, then in this other statement here, I can replace the 85 degrees with what it's equal to, the measure of angle X. And when I do that substitution, I get this fact. Creating this fact is necessary for my final conclusion. Triangle ABC is similar to triangle XYZ. Justified by side angle side, similarity. And now I have to collect the two corresponding proportional sides and the corresponding angle in between those sides and point them towards my conclusion. This is a formal proof, and all formal proofs can end with a conditional statement, an if-then statement, where what comes after the if is all the given information, and what comes after the then is the conclusion that you reach. If AB is equal to 4, AC is equal to 6, XZ is equal to 3, XY is equal to 2, angle X is 85 degrees, angle B is 60 degrees, and angle C is 35 degrees. That's all of the given information. Then the conclusion must be that triangle ABC is similar to triangle XYZ.